We're going to start in section 10-2, which is on simplifying radical expressions. And again, we did this as a review for our EOC, so hopefully you guys know how to do this and it's such a good deal. If you don't have a calculator, you're definitely going to need one. So grab one and do it. So let's talk about how we do this, and then we'll look at some examples. So it's for any non-negative real number, a and b, the square root of a times b is equal to the square root of a times the square root of b. Basically, this is what we call the product property before. It says if you're multiplying two numbers, we'll say 4 times 9 underneath a radical, we can break it apart and give each number its own radical, and then simplify from there. It's also stating you could go the other direction. If you were multiplying two numbers in their own radical, you could put them both under the radical together. So we're going to be using these radicals to help us simplify some expressions. Now, when we're simplifying these radicals, we're going to be looking for perfect squares. So I want to make a list of perfect squares on our notes. Let's do that next. 1 squared is 1, so 1's a perfect square. 2 squared is 4, 3 squared is 9, 4 squared 16, 5 squared 6 squared 7 squared 8 squared 4, 9 squared is 81, 10 squared 100, 11 squared 121, 12 squared 144, 13 squared 14 squared. We'll do 15 squared. What's 15 squared? So this is just a small list of the perfect squares. We could keep going. We could go on forever, I guess, if we wanted to. This is a small list. These are some that we might see, some more common perfect squares that we might encounter. So let's go ahead and jump into some examples. Anyone need this slide? Here's our first example. We have square root of 52, or sometimes we call that radical 52. On your calculator, take the square root of 52. Square root of 52. And I got something approximately 7.211102551. And that's going to keep going. It doesn't stop there. I don't really want my answer in a decimal form. I want to leave it in simplest radical form. So in order to do that, I need to find a number, a perfect square, that goes into 52. Look at your list that we just created. Do any of those numbers go into 52? Is 52 divisible by any of those numbers? Well, what I would do is just start with 4. 52 divided by 4, does it go in evenly? It does. Now, look at 13. Does 13, is it divisible by any of the numbers on our list? I don't think so. 4 doesn't go in, 9 doesn't go in, 16 is too big. So I think 4 and 13 are our best two options. So let's replace 52 with 4 times 13. Now using that product property that we just talked about a second ago, it's allowing us to break this radical apart and say radical 4 times radical 13. I wanted to give 4 its own radical because we know it's a perfect square. Well, what is the square root of 4? 2. So I'm going to say 2 times the square root of 13. And that is my answer. Let's try another one. the square root of 80 or radical 80. First thing I would always try is to see if 80 was a perfect square. So square root of 80, 8.944271191. Okay, definitely not a perfect square. So let's try a different approach. Let's find a number that goes into 80 that's a perfect square. So from our list, what number goes into 80? 4 does. 8 and 10 go in, but 8's not a perfect square, and there's 10. So I'm going to start with 4. 4 times what? 80 can be broken down into 4 times 20. Everybody agree with that? Now, can 20 be broken down again? Yes. What number from our list goes into 20? 4. Did everybody see that? 4 went into 80, 4 times 20, but 20 can be broken down. It has a number that goes into it, 4 times 5. So what I want you to do is multiply those perfect squares. What is 4 times 4? 16. All right, so let's go back. Let's go back to 80. 16 times what gives me 80? Or take 80 divided by 16.
5.
5. I can use 4 and 20, but it's not the best choice to use because I'm going to have to break down 20 again. So to save me a little bit of time, I'm going to use 16. Does everybody see where I got 16 from? I broke 20 down, and then I just multiply those perfect squares. Okay, so 16 is probably my best choice. Let's use 16 and 5. 16 times 5. Using our product property, we'll break this apart. Give each number its own square root, its own radical. What is the square root of 16? 4. 5's not a perfect square. None of our factors go into or divisible. 5 is not divisible by any perfect square, so that is my simplified answer. 4 radical 5. How about the square root of 54? Let's try that one next. Let's first try to see if 54 is a perfect square. We should know it's not a perfect square, it's not on our list. But just to confirm, it's 7.348469228. Definitely not a perfect square. So what number from our list goes into 54? 4 doesn't go in. 6 times 9. Now 6 isn't on our list, but 9 is, so it'll work. Let's use 9 times 6. And when I'm writing this, I always put my perfect square first. So when I take the square root of it, it's going to be in the front. Okay, so let's break apart this radical and give each number its own square root. What's the square root of 9? 3. So we have 3 radical 6. What about the square root of 180? Okay, so from our list, well, I guess let's check. Is 180 a perfect square? No, I've had a long decimal again. 13.41640.786. So I know it's not a perfect square, so that's not going to work. What number goes into 180? 5 and 36. What if we had used 4? Jamie, your answer is correct, but I just want to show you guys something. 36 times 5 will work. But what if we use, like, does 4 go into 180, for example? But it's 4 times 45. Everybody okay with that? But 45 can be broken down again because what number goes into 45? It's a perfect square. 9. So 9 times 5. So if we take 4 times 9, we get 36. And that's what Jamie told us is correct. So let's just keep rolling with this. The square root of 36 times the square root of 5. The square root of 36 is 6. So we have 6 radical 5. And for you guys to try this next one on your own if you would. What number goes into 9 that's a perfect square? 3 goes into 9, or 45. 9 and 5. 9's a perfect square, so we're going to use 9 times 5. Square root of 9 times the square root of 5. What's the square root of 9? 3, so we have 3. Radical 5. How many of you said letter B is your answer? Good job. B is right. B is right. Try this one real quick. Oh, actually, we can't try that one. We'll do this one together. Sorry. Square root of 2 times the square root of 24. Okay, remember when we talked about that product property a second ago? I said that if we're multiplying two radicals, that we can multiply them together underneath. Okay, we're going to apply that here. So I'm multiplying these two radicals. I could go ahead and multiply them under the same radicals together. And 2 times 24 is 48. Now, could we simplify this? Is there a number that goes into 48 that's on our list? I believe so. What goes into 48 that's on our list?
16.
4 goes in, somebody said 16, which I think is fine. We'll come back to that. 4 times 12 gives me 48, right? That would work. But 12 can be broken down into
3.
Yeah, 4 and 3. So then 4 times 4, by perfect squares, if I multiply the perfect squares, I get 16. So 16 times what? 3. Square root of 16 times the square root of 3. Square root of 16 is 4, so we'll say 4 square root of 3. Now there is another approach that we could have taken. Now, instead of multiplying these, we call those radicands, 2 times 24, I could have recognized, all right, 24 could be broken down. Anybody recognize that 24 could be broken down? You could do it that way. What number goes into 24 that's a perfect square? 4. Bring down the radical 2 for the time being. So 4 times 6. And what is the square root of 4? That's 2. Now I still have a radical 2, and I still have a radical 6. Now, multiplication is commutative, so I could rewrite this as 2 square root of 2 times the square root of 6, right? Which is 2 square root of 12. Is that the answer I got over here on the left side?
No.
I'm almost there, but not quite. What can 12 be broken down into? Well, I can't use 6 and 2 because 6 isn't a perfect square, neither is 2. 4 and 3. Never. Move this up a bit. Let's bring 12 down and we could use 4 times 3. What's the square root of 4?
2.
2 times 2 times the square root of 3, or 4, radical 3. I got the same answer, didn't I? This way, Penny took a few more steps over here on the right, in the red color. It took a few more steps, but it doesn't matter. Sometimes you might recognize you can simplify something up front. Go for it. If you'd rather multiply and then simplify, that's fine too. It really doesn't matter which approach you take. Look at this next example. We have the square root of 2 times the square root of 14. I don't think this one can be, you can't simplify the square root of 2 anymore, and you can't simplify the square root of 14 anymore. So our only option here is to multiply. What is 2 times 14? 28. Now, can the square root of 28 be broken down? Yes. What number goes into 28 from our list? 4 times 7. 4 times 7. What is the square root of 4? 2. So we'll say 2 radical 7. this one, the square root of 5 times the square root of 10. Neither of these can be simplified. The only option is to multiply. What is 5 times 10? 50. Okay. That would work. We can break 50 down into 25 times 2. The square root of 25 times the square root of 2. What is the square root of 25? 5. Radical 2. And remember, just check out your radicand, radicals, to make sure that you can't break it down anymore. And of course, 2 can't be broken down any further. How about this one? Square root of 6 times the square root of 8. Now, 8 could be broken down, right? I could go ahead and multiply. What do you guys think? Go ahead and multiply. We can do that. 6 times 8 is 48. So what number goes into 48 that's a perfect square?
16.
What do you say? 16 times 3? That would work? So square root of 16 times the square root of 3. Square root of 16 is 4 square root of 3. I want you guys to try this one, please. Can we break down the square root of 5 and the square root of 35 to start? I don't think so. I don't think there's a factor of either one that's a perfect square. So I think our only option is to multiply. What is 35 times 5? Square root of 175. What number goes into 175 that's a perfect square? 25. 25 times 5 times 7. And the square root of 25 is 5. So we'll say 5 radical 7. Alright, I'm going to stop here for today. Just remember, we're trying to simplify radicals. We want to find factors that are perfect squares. One other reminder is to make sure that your radicand, that's what we call that right there, what's left under the radical is broken down as far as it can be broken down. Make sure that there's no factors of, say, 7 that are perfect squares. Your assignment's going to be out of your textbook for today. If you didn't bring your textbook, you're welcome to borrow one. Just trade me something to remember to give me the textbook back. But give me just a second and I'll have the assignment put up on the board for you. Started.
Wait. Okay, guys, there is your assignment for today's lesson.